then P2, and P1 is less than or equal, and this is the claim. He said, check that P1 is bigger than P2. The proportion in P1 is bigger than P2. Okay, guys, this is 2 prop Z test. This is the only test for proportion, so it shouldn't be confusing at all. All right, and let's do the math together with the calculator on. Stat tests. Two prop Z test. Okay, X1 is 405. N1, 750. Remember, X1 is always smaller than N1. X2, 375. N2, 750 again. We need to check that P1 is bigger than P2, guys. And then hit calculate. Okay. I got what I need. I got Z equals 1.55 and P to be 0.0605. Okay, I'll remove the calculator and write them down, guys. Okay, is this bigger than alpha or smaller than alpha? Alpha is 0.05. Well, this is 0.0. I have a 6 as a second digit. I have a 5, so that must be bigger. Even a slightly bigger, guys, is still bigger. So you fail to reject HO, and then you're right, since the claim in HA, same thing as about the previous exercise. There is not enough evidence at the 0.05 level of significance to support the claim that the proportion of voters who registered was bigger in group 1. And that concludes the question, guys. That's number 4. Any questions? All right. Let's continue with the next question. Okay, so let's see what we have here. Okay, so 8.4, now 8.3. That's very, very important section, guys. Now 8.3, the difference between 8.4 and 8.3 or the other section, these are dependent samples, so you should expect a table here. And I'm gonna spend some time here explaining this one. So let me read it first, and then I'll show you the table. It's on the next page. All right. During a national presidential campaign, Professor Adams asked each of his political science students to do the following project. Before each upcoming national debate, select 9 friends to do the following. Before the debate, and then you guys should expect after. This is what dependent sample is. Rate the Republican candidate on a scale from 0 to 10. 0 is very negative and 10 very positive. Then after they watch the debate, the same person will rate the candidate again on the same scale. Mary did the project using a random sample of 9 of her friends. The results are shown in the accompanying table. Use 5% significance level to test the claim that the rating before and after the debate are different. All right, so let's go now to the page that has the table. And we want to check if the ratings are any different. Here is the table, guys. So it's question 5. All right, can you guys tell me, someone remind me, what should I do with this problem here? He wants to check if the rating, if those person, the same person, if their rating before and after the debate were different. What do we do? Find the difference. Very good. Okay, so we're gonna do the difference, D. Because they are dependent, guys, don't rush to do it. It's just like 2 sample t-tests. It doesn't work like that. Okay, 6 minus 8, guys. So I'm gonna do before minus after. And then we'll discuss the sign. Okay, 6 minus 8, I have -2. 9 minus 7, I have a 2. 1 minus 1 is a 0. -2, -3, -1, -5. I think that should give you a hint of what you should be doing. What do you notice? I noticed that the rating after the debate improved, as you can see, from 6 to 8. Person number 2, no, he lowered his or her score. Person number 3, the same rating. Person number 4 gave a better score to the Republican candidate. So is 5, so is 6, so is 7. 8, no, didn't like the person after the debate, because from 6 now the new score is 4 and a 3. So we will be testing the difference. This, guys, is gonna go to L1. And after this goes to L1, we're gonna set the null and the alternative hypotheses. And I'm not gonna set it myself. I want you to help me. See if you still remember what we did. Mean of the difference, mean of the difference. Can you tell me against what we test this one? We don't put mu1 and mu2. We're testing only the difference. So it will be against the value, what? What do I put on the right-hand side right here? Yes, 0. Okay. He says the rebates are different. That's easy, guys. Just different here. Equal to 0. So we're gonna check if the ratings were different. He didn't say improve or go higher or go lower. It's just say different. So it's as simple as that. And let's do this together. All right, so I'll go to my calculator. See how valuable the calculator is. Stat, edit. Okay, let me clear here. L1. And put your data. Let's put it together, guys. So let me just give you room to write it down. -2. Again, guys, just a negative sign is right here. Cannot use this. This is minus. So it has to go to in the middle of something. But here you start with negative right here. So -2, enter. 2, 0, -2, -3, -1, -5. I think we're going to be able to support the claim that they are different, and -1. And now, guys, you go to stat, calc, tests. It's t-test. Always in this section, it's a t-test. You can put a note here. T-test. And we're testing against 0. And it's data, first of all. So you have to select data. You're testing against 0. L1. And not equal to, as you can see. And let's hit calculate now. Okay, T is -1.474. Let me write it down. And p-value, guys. Oh, wow, we didn't reject HO. 1786. 179 because 4 decimal places, yes. Okay. So let me just make sure I didn't do anything. -2, no. Stat, tests, t-test, 0, L1, yeah. Okay. So this is bigger than alpha, guys. And what do I type here when it is bigger than alpha? Can a student remind me if the p-value is more than alpha? We say fail to reject the null hypothesis. And then since the claim is in H8, you see this, the third question, we get the same conclusion. There is not enough evidence at the 5% level of significance to support the claim that the ratings are different before and after the debate. We could not make this conclusion. Although they appear to be different, but we couldn't make this conclusion. So not enough evidence to support, yes. All right, guys, so that's question number 5. Any questions before I move to the next one? I'm gonna try to do as many as I can, so you'll have enough review to use to prepare for the next test. So again, guys, the hint for you to know whether you have to use, this is a t-test, only simple, single t-test. To know that you have to do the difference, when you have a table, it gives you information before an action and after an action with the same people. Then you know for sure this is gonna be a t-test, dependent samples. And you can see here, guys, before and after. Okay, number 6. Let's do number 6. Carla is comparing automobile insurance premium in Arizona with those in California. A random sample of 10 insurance companies in Arizona yielded a sample mean premium of $727 with a standard deviation 185. So let's write down what we have here, guys. So I'm gonna write it down and then we'll discuss it. Let me just prepare that. So question 6, we have Arizona. I'll show you the writing in a second. And we have California. So it says in Arizona, she picked 10 insurance companies. N1 is 10. And it's got a sample mean X bar 1, which is 727, and a standard deviation of 185. You can see here. Then let's see what about California. Independent random sample of 12 insurance companies in California. So you guys agree with me that N2 is 12. So these are independent. It says independent samples here. Gave a sample mean of 842. X2 bar is 842 with a standard deviation of 225. Okay. Test to see if the data support the hypothesis that insurance premiums are higher in California than they are in Arizona. Okay. So, and what's alpha here? at 5%. So claim premiums are higher in California than Arizona. That's the claim. Okay, guys. HO, HA. And you guys agree with me, since he gave you S1 and S2, it's a 2-sample t-test. And let me see what it says about population variances here. If it didn't say, we do by default a no always. So it is a no if it doesn't say. Yeah, it didn't. So we're going to assume that pooled is no. But I always say that in the problem. Okay, guys. Now I need someone to help me state the null and the alternative hypothesis. Okay, what do you guys say? Remember, mu1 is for Arizona and California is mu2. So what would you guys say here? We wanted to check if the premiums are higher in California than Arizona. Good. So I got some responses. Okay. I know, guys, you're thinking higher should be greater here. But remember, I named Arizona number 1. So if California is higher than Arizona, that means Arizona is what? Lower than California. For example, if I say I have more money than you, that means you have less money than me. Now, why should I put less here? Because I'm starting with Arizona here. This is Arizona, guys. And this is California. So if California is higher, it's still mu1 is less than mu2. Arizona is less than California. That means California is still more than Arizona. Now, what you could have done, guys, you could have read the whole thing and make California number 1 and Arizona number 2. Then in this case, you can put bigger than. But since I started labeling as I read, I ended up with Arizona being number 1. So I just put mu1 less than mu2. And that's the claim. All right. 2-sample t-test. Okay, again, guys, pooled, he didn't say in the problem. They usually say, if it doesn't say, make it a no. But I will say if I give you a problem on the test, so you don't have to guess this out. So stat tests, 2-sample t-tests, guys, and let's put some data in there. So it's a stats, it's a summary. X1 bars, guys, is 727. S1 is 185. N1 is 10. And let me move to the other side and get the other information. X2 bar is 842. I'll project the screen properly. S2 is 225. And then we have a 12. So let me go back now. And now, guys, we're checking that Arizona is less than California, which is the same as California more than Arizona. That's what you need to understand. And then pooled is no. And calculate. T is negative 1.316. And p-value is 0.1016. Okay. So let me write it down. Which is bigger than alpha, guys. Oh, we haven't rejected HO today, if you notice. So fail to reject HO. And our claim is in HA. There is not enough evidence at the 5% level of significance to support the claim that premium are higher in California than Arizona. Any questions, guys, about number 8? Let's see what 8 is about. The Internal Revenue Service gets frequent complaints that their tax auditors are rude and they harass citizens whose returns are being audited. To try to improve public relations, the government conducted a one-day sensitivity training seminars for the auditor. Yeah, a random sample of 10 auditors who participated in the seminar was selected. The data below show the number of complaints for each auditor in the sample for the month prior to the training. And for the month after the seminar. Test the claim that the average number of complaints during the period after the sensitivity training session is less than the average number of complaints before the session. So we want to check, guys. So those auditors, people were complaining about them that they were rude. They don't treat, just the customers right. So what the IRS did, they made him go through some training, and we want to check if after the training the number of complaints reduced. That means the auditors are doing better job in treating, just the customers right. So this is the same auditor, number 1. There was 5 complaints about this person, and then after he did or she did the training, only 3 complaints. 7 went up here. 2 went up, 3 went down, 8 went down to 5, 9 went down to 7, and so on and so forth. So you guys agree with me that these are dependent samples because it's the same auditor before and after the training. So let me do the difference, and you guys can tell me what you want to make the difference is. And alpha here is 5%. So all I need is question 8. Alpha is 0.05. Let me write it down. And the difference, D. So 5 minus 3, guys, is 2. -1, -1, 1. 8 minus 5 is 3. 9 minus 7 is 2. 6 minus 7, -1. 4. So it seems like it worked with some auditors. It didn't work with others. This guy, 10 complaints, went down to 1. 10 minus 9 is 1, and this is -1. Okay. Okay, let's decide now what we're gonna put there. The IRS wants to reduce the number of complaints after the training. So what do you guys think the sign should be here? If we want to reduce the number of complaints, that means if someone had 8 complaints before, after the training, it should be less than 8, 5. So we get 8 minus 5 is 3, which is a positive number. So would you guys agree with me that it should be greater than 0? Yes. And how do I figure it out again, guys? I'll make myself an example. As just I said, let's say one auditor had 12 complaints before the training. If the training works, the number of complaints should be less. So 12, let's say, went down to 9. You just subtract the 12 minus 9, you get 3. You ask yourself, is 3 positive or negative? You say positive, then you put greater than 0. And that's less than or equal to 0. Okay, let's do that together, guys. So we're gonna go to stat, edit first. I have to enter the data. L1. I'm gonna clear it. If you ever guys lose L1, here's how you get it back. You go to stat and then go to setup editor right here, enter. That will give you everything that you had there before. So edit. Okay, L1, I have 2. I have -1. I have -1. I have 1. I have a 3. I have 2. I have -1. I have -1. I have 1. I have -1. There you go, guys. That's L1. And then it's a t-test. Oops, where did I go? T-test. Data, you make sure your input is data here. Against 0, L1, and we need to test that it is greater than. Okay, so enter, make sure to select enter, and then let me hit the draw this time. Oh, big p-value. Oh, we haven't rejected HO today. So I get T to be 0.802, and the p-value, as you can see, guys, 0.2217. T-test, and I'm gonna write down here, input data, L1. So T is 0.802, and p-value is 0.2217. Okay, which is more than alpha. Oh, again, failed to reject HO. I select those problems at random, guys, so I don't plan whether what the results are. It doesn't matter. So fail to reject HO. Every time you have the word fail, guys, you have to start with there is not. Don't forget that. When you do your test online, you select not enough evidence. At the 5% level of significance to support the claim that, there you go, show you, that the average number of complaints after the training is less, that the number of complaints were less after the training. Remember what we said last time about when the problem like this has an increase, you go against it, you go with less than, and we have decrease, you go more than. So so as you can see, it's a decrease. We want to decrease, just the number of complaints. That's why it turns out to be greater than 0. Any questions about number 8, guys? That's again section 8.3. So we reviewed 8.2, we reviewed 8.3, we reviewed 8.4. Probably you're waiting for 8.1. It will come later. So let me see now what the next one is going to be. Oh, 8.4 again. Let's do this one with 8.4, number 9. A random sample of 800 people showed that 120 of them had purchased or were planning to purchase fishing licenses. An independent random sample of 800 people showed that 106 of them had purchased or were planning to purchase hunting licenses. Does the data indicate that the proportion of people who hunt is different from the proportion of those who fish? Use a 5% significance level. What I'm gonna do here, guys, I'm gonna give you a couple minutes to try to be ahead of me and see if our answers will match. So I will pause for a couple minutes and then we'll continue. So work it out, guys, before we do it together. All right. So do you guys agree that when you see the proportion, if they are different, so that's very easy. It's clear. P1 is different from P2 and P1 equals to P2. And it's a two proportion z-test, guys. For fishing, it says 800 were surveyed, 120 of them are planning to get a fishing license. For hunting season, 800, 106. You want to see if the proportions in general are different. So it's two proportion z-test, guys, and let me just run the calculator screen and get this ready. So stat tests, it's two proportion z-test. X1, guys, is 120. Remember, X1 is smaller than N1. Don't mix them up. X2 is, I got 106, 800. And then we want to check P1 is different from P2 and then hit calculate. I hope that all of you had this answer. If not, let me know if I made a mistake. It is possible. So Z is 1.00 and p-value is huge, 3149. Again, we're gonna fail to reject HO. If you're wondering about what is P1 hat and P2 hat, P1 hat, guys, is X1 divided by N1 and P2 hat is X2 divided by N2. So let me write down the results. Z is 1.00, p-value is 0.3149. It's bigger than alpha. Again, you might be wondering what's wrong with the exercises today. Well, nothing wrong. It just turned out to be p-value more than alpha. So you're not doing anything wrong here. You failed to reject HO. And you don't support the claim. There is not enough evidence at the 0.05 level of significance to support the claim that the proportions are different. So probably they're not different. Proportion, guys, again, it's a percent. Any questions about number 9, guys? Please let me know if you have any questions. Oh, okay. I'm getting a question about how to do this. Yeah, I'll tell you. I'll talk about it. Yeah, I know when you do your homework, it asks you to do it in steps. I will talk about this. Okay. The students is asking me about section 8.3 to give an example with degrees of freedom. It's the critical value approach. I will touch on it. However, I will make sure when it comes to the test that you'll be able to do all the work using p-value. Remember, degrees of freedom is a sample size minus 1. Okay, let's go and find. I want to do at least one problem from section 8.1 as well. So let's see what we have right here. So this is at page 2. I'm going to put it on the side. Okay. Question 10. And guys, I have to fix this for question 10. Actually, it's not 8.3, it's 8.2. So that's fixed. And I'm not gonna do that. We've done enough of those. We're gonna go and see This is again 8.2. See how important this section, guys? To sample t-test. He gives you S1 and S2. Here, he gives you S1 and S2. It's two sample t-test. Two sample t-test. That's important. Too many questions. Section 8.3, before and after. Okay. And let me just see what else we have here. Section 8.3, guys, again, before and after. So I'm going to give you a chance to work some of them out. And now I'm going to do section question 16. You can see what it says in 16. It says 8.1 at the bottom. And let's see why this is 8.1. So question 16. Two different methods of teaching French vocab were tried on two independent groups. Method 1 was used with a group of 40 students selected at random. Method 2 was used with a group of 42 students selected at random. So let's do this, guys. Method 1 and method 2. I'm just reading and interpreting. N1, he says, is 40. And N2, he says it's 42. After 1 month, the same vocab test was given to both groups. The average score out of 100 for the group using method 1 was 89. So X1 bar, guys, you agree it's 89. With a known population standard deviation of 4. So do you guys agree with me that this is not S, this is sigma 1? If this is not clear, please let me know. I'll explain it. This is very important because once you put sigma, you have to change the test. It's not a t test, it's a z test. The average score for the group using method 2, X2 bar, was what? 86. With a known population standard deviation of 5.5. So again, guys, this is sigma. Population, look, it says population standard deviation. Test the claim that students taught with method 1 perform better than students who taught with method 2, use 1% level of significance. Okay, guys, so what would go in HO and HA? These are independent, not dependent, so you're safe to put mu1 and mu2. Can a student tell me what about the signs? He wants us to check if method 1 was better than method 2. Okay, who's gonna reply and let us know? Greater than, yeah. Okay. And I'm afraid probably we're gonna fail to reject HO again because they look very close. We'll see. Okay, guys, let's do this. Two sample t-test. All right. I don't have data. I have a summary. Okay. X1 bar, guys, is 89. S1 is 4. N1 is 40. X2 bar is 86. Sorry, 86. S2 is, I got 5.5. N2 is 42. And you guys told me we need to check that mu1 is greater than mu2. Method 1 bigger than method 2. Okay, if it doesn't, what does it say about pool? If it doesn't, we'll select no. But, oh no, Oh, I went to the wrong test, guys. You agree with me? I went to the wrong test. Sorry. To sample Z test. I was wondering about pool. Sorry, it should have been sigma 1, sigma 2. So now we're good. Sigma 1 is 4. Sigma 2 is, what did we have? 5.5. X1 bar is 89. That's recorded. N1, X2, 42. And we need to check that mu1 is bigger than mu2. Now we got the right test. Again, I mistakenly put 2 sample T test. I meant 2 sample Z test. Okay, let's do, we don't care about color. If you don't have it, just calculate. And I got Z to be 2.83 and the p-value to be 0.0023. There you go. Before I move the calculator. We're gonna reject HO. It's the first time. This is less than alpha, guys. And how do I compare? Let me show you how I would compare, you know, just numbers here. I start, this 0 is the same, that 0. Up decimal place, 0, 0. Now, next one. The second digit is 0, the second digit is 1. Since 0 is less than 1, then the whole thing is less. That's how you compare numbers. Yay, it's about time. We reject HO. And if we reject HO, guys, there is enough evidence to support the claim. I agree. A student put this statement at the 0.01 level of significance to support the claim that students taught with method 1 perform better than students who were taught with method 2. I'll just copy and paste, guys. Perform better than those who were taught with method 2. All right. That is question 16, guys. I hope with this review, you know, that stuff is making more sense to you in chapter 8. I'm gonna do one more exercise with 8. That should be a very good review. And this exercise is number 18. You can see there are, so what I'm gonna do, I'm gonna give you some time to enter the data because there's a lot of data in there. Before even I start talking about it, guys, why don't you take a few minutes to enter the data in L1 and L2, and then we'll talk about this exercise. All right, so let me read this question. A university wanted to see whether there was significant difference in age between its day staff and evening staff. A random sample of 35 staff members is selected from each group. The data are given below. Test the hypothesis that there is no difference in the age group. So we have day and evening. Let me just do this one here. It's question 18. Yes, 18. Day, evening. We're gonna call this mu1 and this one mu2. And he says test that there is no difference. So you guys agree that no difference means equal. So this is the claim. This is the first question where the claim happened to be in the null. And HA will be mu1 is different from mu2. It didn't say population variances are equal or not equal, just treat it as not equal. So we're gonna use pooled no. Again, I will make sure to say, but if it doesn't, usually we assume it's a no. We're gonna use 2 sample t-tests, guys. You already put the data in L1 and L2. And I hope we didn't make any mistake in the data entry. So let me show you how to process this one. The reason why I put this one, because I want to show you how to work with raw data as well. Okay, so you do 2 sample t-tests, guys. Data. And make sure, guys, you do the work with me, just in case if I missed anything myself. By default, it's going to give you L1, which is good, L2, which is good. These don't change, 1, 1 always. And we need mu1 to be different from u2. Pooled is no, as I said. And then hit calculate. Ready? Okay, let's see. Let's see what we get. I got t to be -2 point, which doesn't agree with what some students are telling me. And the p-value is 0.0305. Do you guys agree with this, or you think I missed something myself? Did anyone else get the same results? Okay, so probably I did miss anything. So let me just double check, guys. Let me see. Okay, I'm gonna double check. So again, after I fix the mistake, t is -1.680, which agreed with what you guys came up with. P-value is 0.0976, and which is bigger than alpha, which is 0.05. And again, here's how I can tell. The second digit is 9, the second digit is 5. Since 9 is bigger than 5, then it's bigger than alpha. And bigger than alpha failed to reject HO. Okay, if you fail to reject HO, then the claim is in HO. What do we say here? We cannot reject HO and the claim happened to be in HO. So we say there is not enough evidence at the 0.05 level of significance to, and can a student tell me what do I write here? To reject the claim. Very good. I cannot reject the claim. It doesn't mean I support it, but I cannot reject the claim. And you just write what the claim is. Blah, blah, blah. The claim that there is no difference in age between the two groups. I'm gonna write it down. Between the two age groups, day and evening stuff. Again, we use pool no because it didn't say, but I'll make sure, guys, to mention that so you don't have to worry about that. But sometimes I get problems from some other places where it don't, and that's how they treat it. No mention to pool, to population variances. You just by default assume it is a no. Okay, so this is pretty much a review of chapter 8. On Wednesday, I'm going to review chapter 7. So just keep this handout handy for Wednesday. We're going to do more of 7. And what I'm going to do before I let you go, I'm just going to do a little bit of algebra review. It doesn't have to do anything, you know, just with what we did today. It's just a little bit of algebra and to prepare you for the next chapter. Okay. And I'm going to move 3 units up and 2 units right and put a point here. So this is fixed. That doesn't change. That's fixed. Now, if I have an eraser, well, I'm using, you know, just an ink here, so I cannot erase. But let's suppose I can erase this one. Do you guys agree? This cannot be erased. It's fixed. If I erase this point, guys, will you be able to get it back? What do you think? The answer is yes or no. Can we get this point back? So assume that I erased it. It's no longer there. If I want to get it back, I should be able to, because I can start here and then go 3 units up and then 2 units right and get it back. Now, the 2 pieces of information going up and down and going right or left are called ordered pairs. So if you want to label this point, guys, you can label it as 3, 2. If I want to put, this is fixed. This is, they call it the origin. This is where your actions start. Now, if I want to label another point, let's say 1, 1. Here's how you do it. You start always here. This number here, it means that you have to move 1 unit to the right. This number here, it means that you have to go 1 unit up. So you just do this, guys. 1 and then go 1, and this is your 1, 1. In other words, let me show you how we label points on a flat surface. We draw this line here. It's called the horizontal axis. We draw this line right there, and it's called the vertical axis. They call it in mathematics, this is the x, and they call this one the y-axis. And they call this point here the origin. And this is labeled always, guys, as 0, 0. You need 2 pieces of information, how far to the left or to the right and how far up and down. We scale this one, guys, as 1, 2, 3, 4, 5, 6, 7. When we go to the right, it's positive. And when we go to the left on the number line, it's negative. So this is a number line, but it's horizontal. This is also, guys, a number line, but it's vertical. 1, 2, 3, 4, 5, and then you go -1, -2, -3, -4, etc. And this is 1, 2, 3, and this is -1, -2, -3. This is called coordinate system. It has 2 axes. One is the x-axis and one is the y-axis. The x-axis will tell you how far do you move left and right, and the y-axis, it tells you how far you go up and down. So if I want to label, guys, the point now -2, 2. Look how I do it. You always have to start here. You go 2 units to the left because it's negative, and then 2 units up. So it will be right here. This is -2, 2. You can call it, for example, A. B, let's say 0, 3. How do I label 0, 3? 0 means you stay where you are. 3 means you go up 3 units. So it's going to be right here. Let's say C, 3, 0. A 3, 0, guys, is 1, 2, 3, and no, you don't go up and down, so this is C. Let's do one more, just to give you a feel. -1, -1. -1 means you have to go to the left -1 and go down -1. Right here. So this is how you label points on the coordinate system. The whole thing, guys, they call it in mathematics coordinates system. Why it's called a system? Because it has two things, the x-axis and the y-axis, x and y. And this is called ordered pair. X and y are related. Actually, x is called the independent variable and y is called the dependent variable. So they're all attached, all the time attached to each other. Now, so this is to learn about the coordinate system. Anytime you wanna put something on a flat surface, guys, and you wanna locate it, you need two pieces of information, the X and the Y. And actually your computer screen, when the mouse moves from one location to another, it's all X and Y, guys. It's all programmed, you know, just to go from a fixed point and move X and Y. So this is how the flat screen is done. It's all coordinate system. Now, let me ask you this question. If I have a point here, and I want to draw a line that passes through this point, how many lines I can draw? Can you guys tell me? So I have one point. How many lines? I got 4. An answer of 4. Here's one line, guys. Here's another. Here's another. Here's another. I got 4, and I can get 5. And I can get 6 passing through this point. So can you guys guess how many we can draw from one point? What would be the answer? Would you guys agree with me that it's infinitely many that you can pass through? Yes, I agree. A student says infinitely many. Now let's change the gear. I'm going to give you 2 points and you're going to help me. If I fix 2 points on a piece of paper, how many lines I can draw passing through the 2 points? Okay, I'm gonna pause until a student answer this one. So you got 2 fixed points. How many lines can you draw passing? 1 exactly. It's exactly 1. So in order to draw a specific line, guys, with a specific information, you need to know 2 points on the line. If you know 2 points on the line, you can draw the line and there's only 1 line. So let's talk about lines a little bit. I'm gonna draw the rectangular system. And I'm gonna draw those 2 points, 1, 1, and B to B, 2, 5. Let's do that, 1, 1, guys. So 1 unit to the right, 1 unit up. This is A. And B, 2, 5, 2, 1, 2, 3, 4, 5. So this is B. A and B. And you guys, you would agree with me that there is only 1 line that can pass through A and B. This is my line. Okay. Just talk about this and we will be done. Okay. This is the line. Please pay attention to what I'm gonna say. This line, as you can see, this is the x-axis, this is the y-axis. It's pointing up. As you move to the right, guys, this line is pointing up. We say that this line has a positive slope, the steepness of the line. So as you travel to the right, guys, and the line keeps going up, 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 you say this line has a positive slope. And I'll define what a slope is in a second. I'm sure you heard of the word slope, like sloppy roof. It's very dangerous to go on a roof to fix, a shingle or something like that if the roof is very sloppy. Very sloppy means the steepness is so high. So that means a person, just could fall, just if you go up there, if you don't have the experience. But if it is flat, then the slope will be small, if it is a flat roof. Now, let me show you another example of a line that looks different from the one that I drew. Look at this one, guys. What happens as we move to the right here? This is the origin. So as we increase the values of X, what happens to the values of Y, guys? Can you answer this question? They decrease. As X increase, Y decreases. Okay, we call this line with a negative slope. So there is steepness of this line, but it's a negative. So when you see a line, guys, that's going, left to right and pointing down, then it is a negative slope. And this is positive slope pointing up. All right. So in order to distinguish between lines, we find their slopes. Now, let me show you another example of a third line, guys. And you're gonna see what kind of line I'm gonna draw here. This line right here. Do you think it's safe to go on a roof that has this slope? That is, actually the slope here, can someone guess what the value of the slope? There is no steepness at all here. So we can tell what the slope is. Can you guys guess what the value of the slope? The slope is the steepness of the line. This line doesn't look any steep. It's like a flat road, a flat surface. It doesn't go up, it doesn't go down, it's zero, exactly. So this is an example of a line that has a slope of 0. This is the first one, is an example of a line that has a positive slope. And this is an example of a line that has a negative slope. Now, let me show you a fourth one, which we're not interested in at all. This is the X and Y axis, guys, and watch this one. Look at this line. Do you think, guys, you can drive a car on a line like this? Do you think you can drive a car on a line, on a road that looks like this? Yes or no? That's definitely a no, guys. It's impossible. This is a vertical line. Vertical lines, their slope is undefined. Infinity. We're not interested in those kinds of lines because there's nothing we can do with those lines. So this is a slope of 0. This is undefined slope. Definitely, you can drive on a line like this. It's a steep road, but it's possible. That's a positive slope, and that's a negative. And the fourth one, guys, is a negative slope. Before we wrap this up, I'm gonna show you how to find the slope of a line and determine whether it is positive or negative. So I'm just gonna do this example and then we'll stop there. So I'm gonna give you this line, guys. And for your information, you won't do any of the work that I'm doing by hand, but for students who don't know about lines and slope, I need to introduce this topic. So I'm gonna give you this point here. Let's say this is 2, 3. I'm gonna give you this point here. I'm gonna make it up. Let's say this is 5 and 6. And I'll show you how to find the slope. Watch, guys. You do this, you do a horizontal line from here until you're right under the second point, and then you do a vertical line. The slope, by definition, is called rise over run. It's this distance divided by that distance. Where does the rise and the run come from? Is from the airport concept. When the plane takes off, it taxis on the runway and then it rises. So it's a rise over run. Can a student tell me how much is this rise? Remember, this point is a 5 and 6. So this is a 6 right here. And this is a 5 right here. And this is a 2 and 3. This is a 2 here. And a 3 there. And I want this distance. Can you guys tell me what this distance is? Remember, it's from 3 to 6. What's the difference between 6 and 3? Okay, let's see what you guys said. 3, exactly. So this is the rise. The rise is 3. What's the run, guys? The run is from this x to the next x, 2 to 5. It's again 3, exactly. So the slope will be 3 over 3, which is 1. And you shouldn't be surprised that it's a positive slope, guys, because the line is pointing up. Okay, let's do, let me give you a formula for and how to find the slope. You will be given 2 points. We're going to label the first point x1, y1, and the second point it's x2, y2. And the formula of the slope. In math, they call it M. It is y1 minus y2 divided by x1 minus x2. Let me show you that it does work, you know, the way the formula is stated. This is your x1, guys, and this is your y1. This is your x2, and this is your y2. And let me show you that the formula works. y1 is 3 minus y2, which is 6. I should get 1 again. If I don't get 1, I'm in trouble here. x1 is 2 minus x2, which is 5. Okay, what's the 3 minus 6, guys? Is negative 3. And 2 minus 5 is negative 3. And you guys agree with me that negative 3 over divided by negative 3 is positive 1. And this is what the slope is. Before we wrap this up, I'm going to draw 3 lines, guys, and you're going to tell me which one has the largest slope and which one has the smallest slope. This is line 1. This is line 2. And this is line 3. Let me show you here. All of them have positive slopes, guys. As you can see, they're all pointing up. Which one has the largest slope? Is it L1, L3, L2, or L3? L1, okay, I get L1, but L1, it looks like flatter than the others. L3, it's right in the middle. Don't you guys agree with me that L2 is the sloppiest one because it's pointing, it's rising, you know, just a little bit faster than the others. So it's L2. L2 has the highest, largest slope. Which one is the smallest? The smallest, guys, is the one that is very close to being flat. Which one is the closest to being flat? L1, yes. And then L3 is in the middle. You can see L3 is in the middle. Again, guys, the steeper, the higher the slope. Well, you should agree with me that the roof L2 is the steepest roof. And the roof L1, if you're talking about, you know, just roofs, is the less steep, you know, than the others. And this is how you compare them. And if I guys put a fourth line, let's say I put this one, L4. You know L4 is going to be the smallest because L4 has a 0 slope. Okay, I'm going to stop